Hi, hello, very good afternoon one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep, and warm welcome to the session. So today, the third session of Maha Marathon for GATE 2022 aspirants. I am Satya, waiting for you all to join the session. Quickly do join. Chandan Kumar, very good afternoon. So I hope you are really enjoying these Maha Marathon sessions. Already computer organization and architecture classes, Maha Marathon is done, and then we have done programming and data structures yesterday. So Raju, good afternoon. So please do join the session quickly. Madhav, Sunil, Explorer, Dilip Kumar, very good afternoon. So how are you all? And also guys, please do confirm my visibility and audibility. Am I visible and audible to everyone clearly? Dilip, yesterday class was excellent. Thank you. Srina, Pooja, Saubhagya Nayak, Explorer, Sunil Kumar, Raju, Chandan, Dilip. Quickly do join the session, and also please invite your friends for this session. Please invite your friends also for this session. Yep. So give me a moment. Yes. So now guys, BYJU'S Exam Prep becomes one-stop solution, a complete solution for all your GATE problems. So you want to prepare long term, or you want to prepare short term just in 3 months, or you want to prepare for 1 year, or you just want only to practice the problems. So in our BYJU'S Exam Prep, you will get all kind of courses, facilities. So do subscribe to our YouTube channel and kindly share with all your friends. Okay. So before I start, I want you all to invite your friends, share as much as possible through WhatsApp, Telegram, Facebook, Insta, Twitter, wherever it is possible. All right. Now, so this is quick introduction about me. I know it is very boring slide for you. So I am Satya with all these credentials. You can just go through if you would want to. For all the branches of these 5, mechanical, electrical, electronics, civil, computer science, this Maha Marathon is happening from 3rd Jan. For 15 days it will go on. So even if you could not practice well, if you just join this Maha Marathon classes, then definitely your confidence levels will increase. Okay. So let many people benefit out of these sessions. Okay. So before I start, I want to know, if I ask you to rate yourself in this algorithms, how do you rate out of 5? 5 means you are perfect. So if I want you to rate yourself, how would you rate? Quick. So very important, very frequently asked model questions are waiting for you. So if you quickly answer, we will proceed with the questions. Raju 2, Sunil 2, Sambhav 2.5, CSC Fun 4, Navneet Kaur 3, Saubhagya 3, Vikram Jha 3. Okay. Chandan Kumar Jaiswal 3, Rahul Raj 3, Saurabh 1. Okay. At least I am happy nobody has rated themselves 0. Great. So, shall we start the session? I want everybody to show your love and show your Josh in the chat box. Shall we start? Are we ready? Is it good to go? Maha Marathon series is happening from day before yesterday, and it will happen regularly for 15 days. So today we are with algorithm subject. So everybody जोर से बोलना. Are we ready to start? Yes. Good. Superb. So let's start with the very first question of this Maha Marathon today. Consider a double hashing scheme in which the primary hash function is h1 of k equals to k modulus 23, and the secondary hash function is h2 of k, which is 3 plus k mod 23. Sorry, it should be 21. K mod 21. Okay. Assume that the table size is 23. Then the address returned by probe 1 in the probe sequence for the key value k equal to 90 is. Quick, give your answer in the chat box. You have just 1 minute time, 60 seconds time. Hurry up. Anu, good afternoon. So quickly give your answers, everybody. So this is the question from hashing topic. Double hashing. So what is double hashing hash function? H of k is given as h1 of k plus I into h2 of k whole modulus m, where m is the hash table size. Right? h1 of k, here what is I? I is the probe number. Anshul sir, welcome to the session. So we want to find out for probe 1 what would be the slot, what would be the address. So h of 90 we can say like this, h of k comma I. So 90 comma 1 is equal to h1 of 90 plus 1 into h2 of 90 whole modulus 23. Right? Now what is h1 of 90? h1 function is given as k modulus 23. This is 90 modulus 23. This is, what is the remainder? 23 3 times, 4 times means it would be 92. So 3 times, 3 3s are 9, 3 2s are 6, 69 means 21 you will get. Then what is h2 of k? H2 of 90, that is 3 plus K modulus 21. This is 3 plus 21 goes 4 times, and what is the remainder you get? 2. Right? 21 fours 84, so sorry 6, so this would be 9. So substitute here, H1 of 90 is 21 plus H2 of 90 is 9 whole modulus M, that is 23. So this is 30 modulus 23. So what is the remainder? 7. So what is the answer? What is the address returned by probe 1? 7. So those who have given 7, please award yourself, and those who are unable to give, please update your scorecard accordingly. Okay? Prakash, you will keep giving the values. What value shall I take as answer, Prakash? You have given 21, you have given 19. Okay, let's proceed to next question. Question number 2. Consider a hash table with 100 slots. Collisions are resolved using open addressing. What is the probability that the first 4 slots are unfilled after first 4 insertions? Unnati, because we have to find out for probe 1. For probe 1 we have to find out, because that is what the question. So that probe number is what? I value. Okay. So consider the hash table with 100 slots. Collisions are resolved using open addressing. What is the probability that the first 4 slots are unfilled? Yes. Everybody say option A. All right. Here we are having 100 slots. Numbered from 0 to 99. Numbered from 0 to 99. We have total 100 slots here. Now the first 4 slots should not be filled. So these 4 slots we should not give any key. Now remaining how many slots are there? Total 96 slots are there. Right? Now you are doing open addressing. What is open addressing means? In a single slot also, with the help of chaining, you can just keep storing all the keys. One slot can accommodate all the keys also. That is possible. Not mandatory, that is probable. So, if so, the first key, let us assume we are storing here. So what is the probability that you will get this particular slot? The first 4 slots you cannot. Out of 100 out of 100, in any of these 96 slot you can get. Similarly for the second also, second insertion also, you may get the same, or you may get some other also out of 96. Similarly for the third and fourth. So this is altogether 96 into 96 into 96 into 96 divided by 100 to the power 4. Right? Guys, suppose if I change this to, if it is not open addressing, suppose if I change this from open addressing to linear probing or quadratic probing or double hashing, means if I change it to closed addressing scheme, then what would be the value? What would be the probability? Everybody? If it is not open addressing, if it is a open hashing scheme, then what? Guys, keep liking the session, keep sharing. I see only 31 likes, though around 60 are watching. Please do show some love by liking the session, guys. Okay. Yes, please. Very good. So, I understand what is your clarity in the subject with this. Guys, open addressing itself says closed hashing, right? Here only we will get linear probing, quadratic probing, double hashing. The question is open addressing. But for what we have solved? We have solved for what? Chaining method. Which is not open addressing scheme. Right? So, if it is open addressing, it could be linear probing or quadratic or double. Only one key you can place in one slot. If collision occurs, you will go for the next probe. Right? So, if it is open addressing scheme, then for the first insertion, you have 96 slots out of 100. For the second insertion, that particular slot is now filled. You will have 95 only. For the third insertion, 94 only. And for the fourth insertion, 93 only. So all together, it would be 96 into 95, 94, 93 whole divided by 100 to the power 4. So the answer is B. For this question only, answer is B. Huh? Everybody said yeah. That shows your clarity. And I see some people have identified it. I really appreciate them. Very good. So you should be clear enough. Right? Next question. If it is a separate chaining method, then it is option A. But the question is open addressing. For open addressing, it would be option B. Right. Next question. The recurrence relation for brute force approach of 2 n by n matrices multiplication is. Raju, for any open addressing scheme, the answer would be same, because in open addressing, in one slot only one key you can place. So first 4 we are however omitting. So you have 96 for the first insertion, 96 options you have out of 100. Let's say you have selected some 5th slot for the first insertion. For the second insertion, you have how many? First 4 already omitted, now 5th slot also omitted, so you have how many? Remaining 95. For the third, 94, like this. Okay. Yes, the recurrence relation for the brute force approach of 2 n by n matrices multiplication is. Guys, please try to use the question number while giving the answer. I think everybody know how we multiply matrices. Let's say I am taking two 3 by 3 matrices. What we do? We will pick the first row and we will multiply with first column elements. Similarly, second row with second column, third row with third column. Means for total we will get 9 elements. For 9 elements, how many multiplications we are doing? For 9 elements, how many multiplications we are doing? That is what matters. Actually, what we are doing here, suppose if you take n as some even number, let's say A11, A12, A13, A14, A21, 22, 23, 24, 31, 32, 33, 34 and 41, 42, 43, 44. With this, I am multiplying. Just have some patience. I am making it ready for you. Four one, 4-2, 4-3, 4-4. What actually we can do here? You can divide this matrix into four parts. This and this you can multiply. This and this you can multiply. Like this. What we are actually doing, we are actually making n elements into n by 2 elements. In that way 8 times we do, so it is definitely 8t of n by 2. Then each time for 2 matrix multiplications, you know matrix multiplication, right? For I equals to 1, I less than rho I plus plus. For j equals to 1 means all the rows of all the columns, of all the rows we will traverse. So if this is n, this is n, this would be n multiplied by n. This is n square. So for one small matrix multiplication, we require n square computations. Like that, 8 small matrices or 8 times we do. So it is 8 t of n by 2 plus n square. Option D. Sambhav Jain, please update your scorecard accordingly. Next. The number of movements required in Towers of Hanoi problem with n square discs is. For Strassens, it is 70 of n by 2. For Strassens, it would be 70 of n by 2. Yes, Yathin. The number of movements required in the Towers of Hanoi problem with n square discs. If it is with n discs, then how many movements are required? 2 raised to n minus 1. But now n is equal to n square. So this is 2 raised to n square minus 1. Option C. Next, the time complexity of the recurrence relation T of n is equal to 8t of n by 2 plus n cube is. This is the recurrence relation which can be solved using master theorem. Oh, so Sobhagya Nayak, you don't know Towers of Hanoi problem. You will be given 3 towers and discs. Let's say tower A, B, C. You should move the discs from tower A to tower 3, tower C, such that always smaller discs should be on the top of bigger disc, not vice versa. It's even a game that we used to play in the childhood. So what is the answer for 5th question? N cube log n. Master theorem. For dividing function, if you see, it is in the form a into t of n divided by b plus n to the power k log to the power p n. Just if you relate the given one, 8 into t of n divided by 2 plus n cube, here a is 8, b is 2, k is 3, p is 0. It is log to the power p, not log p, log to the power p n. Now what we do, we will compare a and b power k. Here a equals to b power k, 8 equals to 2 cube, right? So for you, I have kept master theorem here. If anybody don't know, in this PDF you will have that also. We will have 3 cases basically. A greater than b to the b power k, a equal to b power k, a less than b power k. So first we will extract a, b, k, p values, and we will first find the relation between a and b power k. Accordingly, we can directly write the complexity. Here a equals to b power k, and what is the subcase? P greater than minus 1, equal to minus 1, less than minus 1. What case is satisfied? P greater than minus 1 case is satisfied, because P is 0, no? Right. So when P is 0, what it says? P greater than minus 1 satisfied. So this we can write as theta of n to the power log A base B log to the power P plus 1 n. So this is theta of n to the power log 8 base 2 log to the power 0 plus 1 n. So this is theta of n cube log n. Okay. Clear? Next question. If anybody don't know master theorem, here I have kept both master theorem for dividing functions, master theorem for decreasing functions. इतना यार है, पूरा क्यों ना यार? Next. So the next question is again recurrence relation, the time complexity of the recurrence relation t of n equals to 3t of n by 3 plus square root of n is. Virendra Singh, yeah, I think our team will share. Chandan Kumar Jaiswal, please share the Telegram link. Here A equal to 3, A equals to 3, B equals to 3, N is not N, K equals to 1 divided by 2, P is equal to 0. Here A is 3. So what is the relation between A and B to the power K? 3 is greater than square root of 3, right? So A greater than B to the power K. So according to master theorem, A greater than B power K, case 1, then it is simply theta of n to the power log A base B. So this is theta of n to the power log A base B. This is theta of n to the power log A base B. Log 3 base 3 is 1. So this is theta of n. Good. Aditya Pratap, please update your scorecard. Guys, keep updating your scorecard, and if you do some question wrong, please mention why you are unable to give the correct answer for that question. Is it lack of subject knowledge? Is it a calculation mistake? Is it in the hurry you did not read the question properly, or you did not read the options properly? So that at the end you will identify total how many mistakes you are doing and what kind of mistakes you are frequently doing. Okay, that is the way to assess yourself. Next question. Consider two strings, capital A equals to QPQRR, B equals to PQPRQRP. Let X be the length of longest common subsequence and Y be the number of such longest common subsequences. Then 2x plus 3y equals to Shreya at 1:30. Yeah. What is the answer? Question number 7. What is the answer? Guys, keep liking the session and sharing. Please invite your friends for this session. So what is common subsequence? The sequence, the order should be same. It need not to be contiguous, means it need not to be continuous, right? So here in A and B, what are the common subsequences? If you find out some subsequences, I'll write like, do I have QPQ? QPQ, yes. This is one. Do I have QPQR? QPQR. In the same order it should fall. Yes, I have QPQR. Do I have QQRR? QQR? No. QQRR is not there. Do I have PQRR? P? Yes. PQRR. Yes, that is there. And do I have QPRR? QPRR. Yes, I have even that also. And do I have QPQRR? QPQRR. No, we don't have that. And I have PQR. PQR is there. And do I have PRR? Yes, I have PRR also. Like this, there could be many common subsequences. Among these, length of longest common subsequence, if you find out, this is one longest, this is one longest, this is one longest. So length of longest common subsequence is 4. And how many such subsequences have occurred? QPQR, PQRR, QPRR, and do we have QQRR? No. And that's it. That is the possibility. So number of such occurrences equals to 3. It's given length of longest common subsequence be x and such number is y. So 2x plus 3y would be 2 into 4 plus 3 into 3. This is 8 plus 6, 14. No? sorry, 3 into 3 is 9. See how good I am in mathematics. Yes, option C is the right answer. Prakash, please update. And Raju, no, it is not option D, it is option C. Okay. Right. Let's proceed to next question. Consider 4 matrices PQRS with orders 2 by 3, 3 by 4, 4 by 3, 3 by 2. The first product that can be happened in order to obtain the result in optimum number of multiplications. Okay, Chandan, that's okay. Please concentrate in the session. So what is the first product that can happen to get the result in the optimum number of multiplications? It's a MSQ question, guys. Do it quick. CSC fun. Yeah, see, when we are doing with coding, definitely you can use DP, but like this, when you are doing manually in the competitive exams, if you follow DP, forming that table tabulation method, it takes more time. Instead, you can just analyze. Even this is the question. If you follow dynamic programming, this is what actually MCM, matrix chain multiplication problem, which can be solved using DP, dynamic programming. You have a very effective procedure. We will form 2 matrices. And we use a formula. Using that formula, we will fill the matrix, and finally you will find the optimum number of multiplications and what is that order also. That parenthesis, that bracket, how we divide also we get. But to do all that, it takes more time. So if you are doing coding, like you are doing competitive coding, then definitely you can use that DP logic. But here, don't do that because it takes time. Ruhi, optimum means in the minimum possible multiplications. Okay. Kaushalya, yes, there can be one choice also. One also can be correct. MSQ doesn't mean always you should have multiple correct. 1 can be correct, 2 can be correct, 3 can be correct, all 4 can be correct. Okay, guys, we want to multiply these 4 matrices. We know to multiply any 2 matrices, the number of columns of first matrix should be equal to number of rows of second matrix, right? So keeping that in mind, what are different ways that you can multiply? First, P can be multiplied with Q. That result can be multiplied with R. That result can be multiplied with S. This is one way. Then P and Q can be multiplied. R and S can be multiplied. These 2 results can be multiplied. This is one way. Then R and S can be multiplied first. Then Q can be multiplied with that. Then P is multiplied with that. This is one way. Then what is the other way? Q and R can be multiplied. P can be multiplied with that. That can be multiplied with S. and the other possibility is Q and R can be multiplied first, then with S, then with P you can multiply. So these are the 5 different possibilities to do multiplication, right? So if you look at the first possibility, to do P into Q, how many multiplications are required? 2 into 3 into 4. 2 into 3 into 4, that is 2 3s are 6, 6 4s are 24. R into S if you want to do, RS again 4 3 2 24. QR if you want to do 3 by 4 by 3, so 3 into 4 into 3, that is 3 4s are 12, 12 3s are 36. PQ, QR, RS. Okay. Now, when you do PQ, what matrix you get? 2 by 4 matrix. That you are multiplying with R. So 2 by 4 with R. P into Q with R. So this will be 2 into 4 into 3. 2 4s are 8, 8 3s are 24. This you are multiplying with S. Now this will produce what matrix? 2 by 3 matrix, that you are multiplying with S. So this would be 2 into 3 into 2, 12. So first P into Q we do, that takes 24 multiplications. That you are multiplying with R, that takes 24 multiplications. That you are multiplying with S, that takes 12 multiplications. So this would be 60 total multiplications required. Saubhagya, it is not saying to multiply all, but to get the result in minimum number of multiplications, first product that you do is what? For that definitely we are supposed to do everything. Now PQ we have already solved 24, RS we have solved 24. Now PQ will produce 2 by 4 matrix, RS will produce 4 by 2 matrix. So PQ into RS, this will give 2 by 4 by 2, 16, right? So this is taking 64 multiplications. Now CSC fun, yes, but we have a clause also, no? The number of columns should be equal to number of rows. We have to check that. Fine. Now first we are doing R into S here. So 24, R into S produce 4 by 2 matrix, that you are multiplying with Q. So 3 by 4 by, so let me write here Q into RS. RS will produce 4 by 2. Then you are multiplying with Q. So this is 3 into 4 into 2, 24. This will produce 3 by 2 matrix, that you are multiplying with 2 into 3. So P into QRS. This would be 2 by 3 by 2, 12. Right? Now what is the other way? QR takes 36 multiplications that you are multiplying with P. So 2 into 3 into 3, 2 3s are 9, 9 3s are 2 3s are 6, 6 3s are 18. Then that will give 2 by 3 matrix. 2 into 3 into 2, 12, 66. Now QR 36, 3 3s are 9, 3s are 9, 2s are 18. Then 2 into 3 into 2, 2 3s are 6, 6 2s are 12. This is also 66. Now minimum number of multiplications, where you are doing minimum number of multiplications, 60. In this, first product that you can do is what? PQ or RS. The first product that you can do is either P into Q or R into S. So A, D should be selected. Saubhagya, did you understand why I have done all? Right. Next. Which of the following statement or statements is or false? Please go through the options. This algorithm may not find optimal solution for negative weight edge graphs. Shreya, we have multiplied all the 4 matrices. In that order means you can't go with Q into P, P into Q only. You can't multiply S into R, R into S only. That is what it means. Okay. So the first option, this theorem may not find optimal solution for negative weight edged graphs. True. That is the drawback of this theorem. This theorem is used to find shortest path from each node to each other node. Each node to each other node is becoming all pair shortest path. Is this theorem is all pair shortest path or single source shortest path? From one node to all the other nodes, will it find the shortest path, or from every node to every other node? Only from one node to every other node. So it's a single source shortest path problem. So this is false because it is not from each node. Bellman-Ford algorithm cannot find optimal solution for negative weight edged graphs with the cycle having negative weight edge. Yes, that is true. Bellman is used to find shortest path from each node to each other node. No, even Bellman-Ford algorithm is also single source shortest path problem algorithm. So this is also false. We want false statement. So B, D. So what you should select? B and D. The one who have given their answer as B, D, they only please award mark yourself, otherwise wrong. Okay. Guys, keep joining your friends for this session. Make the count 100. Next, let A1, A2, A3 and A4 be 4 matrices of dimensions 10 by 5, 5 by 20. Okay. The minimum number of scalar multiplications required to find the product A1, A2, A3, A4 using basic matrix multiplication method. CSC fun, yes, it cannot find the solution, but it will find that there exists a cycle with negative weight. Okay. What is the minimum number of multiplications? In the same way, just now we have done in the same way, we will get 5 possibilities. So if you do A1, A2, then A3, A4, A1, A2, 10 5s are 50, 50 20s 1000, 20 into 10, 200 into 5, 1000, 10 by 20, 10 into 20 into 5, 200 into 5, 1000. So this is doing 3000 multiplications. A1, A2, then A3, then A4. If you do A1, A2, 1000, that produce 10 by 20, 10 by 20 is 200 into 10, 2000, that produce 10 by 10, 10 by 10 is 100 into 5, 500, this is 3500 multiplications. The other way is A2, A3 I can multiply. So A2, A3, 5 into 20, 100 into 10, 1000, then 10 into 5, 50 into 10, 500, that produce 10 by 10, 10 by 10 matrix means 100 into 5, 500. Then the other possibility is A2 and A3 can be multiplied, then A4, then A1. A2, A3 we just got 1000, that produce 5 by 10, 5 by 10 means 50 into 5, 250, that produce 5 by 5 matrix, now 10 by 5, 50 into 5, 250. So probably this is what minimum number of multiplications we get. Okay, let me do the last possibility also, that is A3, A4, then with A2, then with A1. So A3, A4 will give 1000, that produce 20 by 5, then with 5 into 20, 100 into 5, 500, that produce 5 by 5, so 10 5s are 50, 50 5s are 250, so this is taking 1750 multiplications. So which is minimum? Obviously 1500, option A is correct. Good, very good. Madhav, Sakshi, Kiran, Chandan, Kaushalya, Muskan, Dilip, Explorer, CSC Fun. I think everybody have given right answer for this. Good. So 10 questions are over. May I know your score out of this 10? out of 10, what's your score? Okay. Unnati, that is how we got 3000. Okay, so 7 5 8 7 6 4 3 6 5 8 5. Okay, good. Anup Kulkarni, no excuse as you have joined late. If you go late for the GATE exam, would you get excuse? No, same. Okay, next. The dash number of bits may be required for encoding the message Maha Marathon using Huffman coding technique. Using Huffman coding technique, if you encode the message Maha Marathon, how many bits would be required? Quick. Firstly, identify how many distinct characters are there. We have M, A, H, R, T, O and N, right? And how many times each character occurs? M occurred 1, 2 times. A occurred 1, 2, 3, 4 times, and H occurred 2 times. R occurred only 1 time. T 1, O 1, N 1. Now we will arrange these characters in the increasing order of frequency. So you can arrange in any order. So R, T, O, N, H, M, A. In any other order also you can, but it should be increasing. R 1, 1, 1, 1, 2, 2, 4. Now we will merge the minimum 2. The first least 2 we will merge. So these 2 together will produce 2 characters. These 2 will produce 2 characters. These 2, see, the next minimum is 2, 2, 2, 2, 4. 2 is minimum, so I can merge these 2. The next minimum is these 2. I can merge these 2. Now right? So this is the Huffman tree. Eight plus 4, 12. Now what we do? We will mark all the left edges to 0, right edges to 1, or vice versa. Anyway you can. So if I mark like this, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, left to 0, right to 1 I am marking. Now if I want R from root 0, 0, 0, 0. So R I am writing 0, 0, 0, 0. T 0, 0, 0, 1. O 0, 0, 1, 0. N 0, 0, 1, 1. H 0, 1, 0. M 0, 1, 1. And A is simply 1. Right? Now how many bits we have for M? 3 bits. And how many times it occurs? 2 times. So what you do? Summation of frequency into number of characters, number of bits. This is what you do. So this is 2 into 3 plus 4 into 1 plus 2 into 3 bits plus 1 into 4 plus 1 into 4 plus 1 into 4 plus 1 into 4. This is 6 plus 4 plus 6 plus 4 plus 4 plus 4 plus 4. 5 times we have 4, 5 4s are 20 plus 12, 32. So the number of bits required is 32. CSE fun, if one character require 1 bit, we just have 12 characters there, so only 12 bits could have been required. Only A require 1 bit to represent. Okay. Right. Next question. Consider elements 17 to 20 are sorted using insertion sort. The order of elements after 5th pass is, you can combine any two, but you will get the same number of bits. Anup Kulkarni. That is what the beauty of Huffman tree. It just says the least among the given, merge the first two least sets. So instead of that, you can merge even M and A also. Yes. Yep. First, given elements are 17, 12, 5, 30, 10, 27, 42, 20. Now, insertion sort makes what? In past one, find the least element and insert in the first position and shift all the elements, adjust all the elements towards left in this way. So 17 comes here, 12 comes here, all the other will be same. Wherever you are picking, there you get a gap, no? So shift. Then pass 2. Second least element is what? 12. Place in the second position. So you get vacant. Shift 17 there. Wait. 10 is second, right? 10 is the next smallest. I did not see. So 10 we will place here. Then the other elements we will shift. That is pass 2 result. Pass 3. 12 you will place in the third position. 5, 10, 12, 17, 30, 27, 42, 20. Pass 4. 17 in the same place. So you will get the same 5, 10, 12, 17, 30, 27, 42, 20. Now pass 5. Where you will place 20. 20 is the next one in the 30th place. So 5, 10, 12, 17, 20 and all the other elements shifts right. 30, 27, 42. Very. So 5, 10, 12, 17, 20, 30, 27, 42. I think option A. Right? So pass wise you have to practice. At the end everybody know the list would be sorted, but in which pass how the list would be, that is main important. Next, which of the anonymous, no, selection sort simply swap, insertion sort is what I have done. Maheshwari, selection sort simply swap. I think I have kept a question. I'll show what is that selection sort also. Which of the given options provides increasing order of asymptotic complexity of the functions f1, f2, f3 and f4? Guys, keep liking and keep sharing the session. Yes, what is your answer for question number 13? here which is bigger? We want increasing order, means ascending order. N log n is smaller than n power 3 by 2 than n to the power log n than 2 power n. For this I told many times, though you don't know anything about this asymptotic notations or time complexities, just keep some bigger value for n and you will get it. Like let's say I keep n as some 16,536 or 65,536, let's say. So n log n would be 65,536 into log 2 power 16. This is 65,536 into 16. That would be less than 65,536 whole to the power 3 by 2. This is 2 power 16 whole to the power 3 by 2. So this is somewhere 2 to the power 24. That would be bigger value than this. Then 65,536 whole to the power log 2 power 16, that is 16. 2 to the power 65,536. If you keep some bigger values, then easily by substituting you can understand which is small, which is big. But don't take small values like 16, 64, 1024, then it would be some misunderstanding. Okay. Next. Which of the following hash functions on integers will distribute keys most uniformly over 10 buckets? Numbered 0 to 9 for I ranging from 0 to 2020. CSC fun as you wish. Nishu, which hash function we have to find out? And this is a previous gate question. If you remember, you can give the answer. Option A. Guys, before that, if you see here, all are having mod 10. Mod 10 means when you do mod 10 for any value, mod 10 will give the LSB value. 72 mod 10 means 2. 47 mod 2 mod 10 means 7. So LSB value you will get. Any number you do mod 10, right? So what are the possible LSB values? 0 to 9 only, right? So here I am taking LSB values like 0, 10, 20, 30, 40, so on to 2020. 1, 11, 21, 31, so on to you can say what 2001, 2011 also. I am taking only LSB values of all the numbers of 0 to 2020. Only these we will get. LSB means. Now, if this is LSB, if this is going to be I, what would be I square? Again LSB 0, 1, 4, 9, 6, 5, 6, 9, 4, 1. Now I cube 0, 1, 8, 7, 4, 5, 6, 1, 2, 9, right? Now 11 into I square, I am writing only LSB values. So 11 into 0, 110 mod 10, 0 only, 110 LSB. 1 into 11, 1, 11 LSB is 1, 4, 9, 6, 5, you will get the same LSB. 12 into I, 12 into 0, LSB will be 0. 12 into 1, 12, LSB is 2. 12 2s are 24, 12 3s are 36, 12 4s are 48, 12 5s are 60. Right? Now I square mod 10. So option A, I square mod 10. 0 mod 10, 1 mod 10, 4 mod 10, 9 mod 10, 6 mod 10. So you will get the same value. Here if you observe, do you have slot 2, slot 3, slot 7, slot 8? Here slot 2, 3, 7, 8 are missing. So how come it is a uniform distribution? Only these slots are getting the keys. Slot 2, 3, 7, 8 are not getting. So if you do option B, I cube mod 10, I cube is 0, that one. So you will get that 0, 1, 8, 7, 4, 5, 6, 1, 2, 9. No, it will be 3. 7 7s are 49, 49 7s are, okay, it would be 3. So here if you see, all slots we have got, all the buckets, bucket 0, bucket 1, bucket 2, bucket 3, all buckets we have got. So this is uniform distribution. And 11I square, again you don't see slot 2, 3, 7, 8, and here you don't see any odd number buckets. Here there is no odd number bucket. So Saubhagya, omega of n, not theta of n. Option B is the uniform distribution. Okay, next. Consider a fractional knapsack instance. Knapsack weight. Oh, wait. Theta plus omega equals to theta. Correct. I thought big O. Right. Theta plus omega would be theta only. The overall profit gained by greedy solution is the overall profit gained by the greedy solution is. What is your answer for question number 15? Everybody. What greedy solution says? First calculate profit by weight ratio. 18 by 9 2, 6 by 3 2, 14 by 6 2.33, 10 by 5 2, 8 by 7 1.1, 4, 7, something like this. Now, what greedy says? Which has highest profit by ratio, pick it. So, pick I3. So, if you pick I3, its weight is 6. So, what would be the remaining knapsack weight? 19 minus 6, 13, and gained profit would be 14. Then what is the next highest profit by weight ratio? I1, I2, I4. You can pick any, right? So let's say I pick I1. So if I pick I1, out of 13, 9 is gone. So 13 minus 9, 4. So I just have more 4 knapsack weight. Profit I would gain is, already I got 14 profit. Now I get 18 profit. So 32 is the profit I got. Now the remaining knapsack weight is 4. I2 and I4 I can pick because they have more P by W ratio. I3, I2 I can pick. I4, 5. As it is a fractional knapsack, you can pick I4, but 5 by 4 only. So I am picking 5 by 4 of I4 only. Or else you can pick I2, then 1 by 4 of I5. As you wish. So if I pick 5 by 4 of I4, sorry, 4 by 5, right? If I pick 4 by 5 of I4, weight would be 4 minus 4, 0. And what is the profit you gain? 32 plus 4 by 5 of profit. So you will get 32 plus 8, 40. So the overall profit gained would be 40. Okay. Next, the characters A to H have the set of frequencies based on the first 8 Fibonacci numbers as follows. A Huffman code is used to represent the characters. What is the sequence of characters corresponding to the following code? So we have A1, B1, C2, means in the Fibonacci every digit is given a character. Yes. So let us form Huffman tree. Let us form Huffman tree. A is combined with B. That is combined with C. That is combined with D. That will be combined with E. Then F. Then G. Finally H. As usual, you can give numbering 0, 1, 0, 1, 0, 1, 0, 1, like this. So now A means 1, 1, 1, 3, 4, 5, 6 ones followed by 0. B means 7 ones. 7. C means 5 ones followed by 0. D 4 ones followed by 0. E H is 0. Right? Now look at this code. Do you have any character for single 1? No. 1 1? No. 1 1 0? Yes, that is F. Now do you have any character for single 1? No. 2 ones, 3 ones, 4 ones, 4 ones followed by 0. Yes, we have D. Then only 0 do you have? Yes, we have, that is H. Then again 3 ones followed by 0, E. 1 followed by 0, G. So the given binary sequence is decoded as FDHEG. Do we have that? Option A. FDHEG. It's option A, Muskan. Okay. Right? Next. If job J1, J2, J3, J4 are given their processing time Ti 1, 1, 2, 3 and deadlines 3, 4, 2, 3, maximum how many jobs can be done? Max, how many jobs can be done? Yes, please. Question number 17, answer please. Use the question number for giving the answers. All right. Here chalo. The maximum deadline is 4. So 0 to 1, 1 to 2, 2 to 3, 3 to 4 if you take. Now job 2 has the time up to 4, and what is job 2 required time? Only 1. So place job 2 because it is giving us as much time as we want to finish and it requires less time. So job 2 I have placed at last. Then job 1 and job 4 both can be done by deadline 3. Job 1 want 1 unit of time, but job 4 want 3 units of time. So if you pick job 4, all this time you should give for job 4 only. So instead you can pick job 1. Now job 3 deadline is 2 and it requires 2 units of time. So we pick job 2 and we will do job 2 first. By 2 units we should complete it. We can do that. Then job 1 can be done. Then job 3 it is. Okay, sorry. Job 3 we will do first, then job 1, then job 2. So maximum how many jobs we can do? 3 jobs. Okay, so this is the problem of job sequencing with deadlines. Right, next. Let G be a weighted, connected, undirected graph with distinct positive edge weights. Okay, it's a PYQ. If every edge weight is increased by the same value, then which of the following statements are true? Minimum spanning tree of G doesn't change. Shortest path doesn't change. Suppose you just take a simple graph with 3 nodes. Let's say the weights are 5, 4, 6. Okay, now what is the shortest path? Spanning tree would be A to B, B to C. What is the shortest path? For B to C, suppose I want for B to C, I can reach from B to A to C, right? Okay, suppose I increase the each edge weight by same value. Let's say I am adding three for each edge, let us suppose. So now the cost becomes 8, 7, 13. So if I increase the each edge cost by same value, now what would be spanning tree? Same. But if I want the shortest path from B to C, now what would be the shortest path from B to C? B to A to C, if you go, it is 15, but here it is 13 only. So shortest path may change, but spanning tree doesn't change. So P only. Okay. Next, which of the following is the tightest upper bound that represents number of swaps required to sort n numbers using selection sort? So here we will see what is selection sort. Yes. Suppose these are the numbers we have. Okay. In pass 1, what you do? Select the least element and swap with the first position element. Insertion sort, you are not swapping. You are up to that you are shifting, but here you are swapping. So this would be 10, 40, 70, 50, 30, 60. In pass 2, select the second least element and swap with the second position element. So 10, 30, 70, 50, 40 and 60. In the third pass, next least element. So 10, 30, 40, 50, 70, 60. In the next pass, okay, just for your understanding, so in the next pass what you do? You will select 50 and swap with the next position element. So 10, 30, 50, 40, 50, 60, 70, 60. In the next pass, you will select 60 and swap with the fifth position element. So how many swaps you have done? 1, 2, 3, 4, 5. How many elements were there? 6. So n minus 1 swaps would be required. Asymptotically, it is big O of n. Okay. Now you got the difference between selection sort and insertion sort. Next question. Which of the following is the tightest upper bound that represents the time complexity of inserting an object into binary search tree of n nodes? What is the tightest upper bound that represents time complexity of inserting an object into BST of n nodes? C, of course C. Because if you take a skewed binary tree, something like this, 70, 60, 50, 40, 30, 20. Is it a BST? Of course it is. Now, if I would like to insert 10, how many comparisons I do? I will compare 10 and 70. I'll compare 10 and 60, 50, 40, 30, 20. At last I decide, yes, it should be here. So I insert 10 to the left of 20. So how many comparisons I am doing? Almost with with all the elements I am comparing. So n comparisons I do in the worst case. But if it is the best case, you might do log n comparisons. For a non-empty, I mean a BST with certain number of elements. Okay. CSC fun, your explanation is great. Thank you. Thank you. Next. The worst case running time to search for an element in a balanced BST with n into 2 power n elements is with n multiplied by 2 power n elements. What is the worst case running time? We are taking balanced BST here, means already it is height balanced. What we call that height balanced BST as AVL tree. AVL tree. So in the AVL tree, what is the advantage? We are making the time complexity from n to log n. If it is just BST, the time complexity is n. If it is balanced BST, the advantage of balancing, the advantage of constructing AVL tree is we will make the time complexity from n to log n. So this is the log n for n elements. But here now we have n value as n into 2 power n. So this would be log n into 2 power n. I can write it as what? Log n plus log 2 power n. Of course base 2. Okay. So this is log n base 2 plus log 2 power n base 2 is what? N. So this is big O of log n plus n, which is bigger. Asymptotically n. Saubhagya, you changed your answer. You have chosen log n. Now you are telling n. Okay. Next. Consider a hash table with 9 slots. Okay. The hash function is h of k equals to k mod 9. The collisions are resolved by chaining method. The following 9 keys are inserted in the order 5 so on to 10. the max, min and average chain lengths. Okay, stop doing your personal conversation. It distracts many. Please focus here. All right. Here, first we take 5. The hash function is 5 mod 9. So 5 mod 9 will get 5. "28 mod 9, 1. 19 mod 9, that also gets 1. It is a chaining method, means in the same slot you can keep even all the values also if required. 15 mod 9, 6. 20 mod 9, 2. 33 mod 9, 6. Oh. "12 mod 9, 3. 17 mod 9, 8. 10 mod 9, 1. Right? Now, what is the chain length? Chain length is 0 because no key is mapped here. Here 3, 1, 1, 0, 1, 2, 0, 1. So what is the max of this? 3. Min of this? 0. Average chain length? 0 plus 3 plus 1 plus 1 plus 1. Only 2 times. Okay, 1 plus 1 plus 0 plus 1 plus 2 plus 0 plus 1 whole by 9. This is 3 plus 2, 5 plus 1, 6 plus 3, 9 divided by 9, 1. So, max is 3, min is 0, average is 1. Okay? Right. Next. Suppose P, Q, R, S, T are sorted sequences having lengths 12, 14, 20, 28, 30 respectively. They are to be merged into a single sequence by merging 2 sequences at a time. The number of comparisons that will be needed in the worst case by the optimal algorithm. So it is optimal merge pattern. P, Q, R, S, T. first we will merge the minimum, as I told, the first two least length keys. 12, 14 are the first two minimum, so merge. This will produce a sequence of 26 characters. But for this, in the worst case, how many comparisons we do? Except the last one, we compare with all the other. So we can say it is 25 comparisons would be required. Okay, first let me merge. Then the next two least are 20 and 26. This will produce 46 character sequence. Then 28 and 30 are next. Now 46 and 58 when you merge, 8, 6, 14, 6 plus 4, 10. 104 character sequence you will get finally. Now the comparisons for merging 12 and 14 length characters, 25 comparisons would be required. Then 26 and 20, 46 if you need to compare, 45 comparisons. Here 57 comparisons. Here 45 plus 57. What? 103 comparisons. So summation of all, what is that? 103, 57, 45, 25. 10, 7, 17 plus 3, 20. 6 plus 4, 10 plus 2, 12. 220 or 230? Oh. 230. Rahul Gautam, you have given wrong. Rohan Kulkarni, you are also wrong. Nishu, you are also wrong. So please update your scorecard accordingly. Next question. The recurrence relation for Towers of Hanoi problem. Very, very popular, very easy. Towers of Hanoi problem, recurrence relation is So I want every one of you to give correct answer for this. Yes? Yeah. Option C. It's a direct question. If you are given n discs, n minus 1 discs, first you will move from tower A to tower C through tower B, then the tower A to tower B through tower C, then the remaining disc, last one, you will move to tower C. So we have recursive procedure. Okay, so the right answer is option C, guys. It's a direct one. Next, the recurrence relation T of n can be formed for the below code as Yes, please. Saubhagya Nayak, at least now you know it. Now you will remember. Yes. What is the recurrence relation you can form for the below code? सर ईसी के बच्चे आ जाए, आज सेशन 2 नहीं ये हमारा। अच्छा bring all your friends also here, EC friends, you can join this session. Yeah, let the time taken by this function on input n, let it be t of n. Then this if condition will be verified one time, so it takes constant time to verify. Then this loop run, how long, how many times? From I1 to, see, when I is 1 less than n true, then I becomes 2 less than n true, then I becomes 4, less than n, then 8. How long this is becoming going to be? Until it is greater than or equal to n, right? So here if you observe, this is 2 power 0, 2 power 1, 2 square, 2 cube, until certain time. So until 2 power k is greater than or equal to n, it is going. So what would be k? Greater than or equal to log n base 2, right? So his for is executing log n times the condition is true, and one more time condition is false, because even that last time also you are verifying. So log n plus 1 times this will be executed, but this printf statement execute only log n times, and if the time taken by function on input n is t of n, then the time taken by the same function with input n minus 1 would be t of n minus 1. So it is the summation of all 1 plus log n plus 1 plus log n plus t of n minus 1. So asymptotically it is t of n minus 1, coefficients can be neglected, log n plus 2 would be log n only. So it is t of n minus 1 plus log n. Very good. Please update your scorecard. So 25 questions are over. 25 questions are over. May I know your score, please? What is your score out of 25? 22, 17, okay, 18, 21, Sambhav 2 or 20, what? Is it a typo? 19, 16, Anu 5, Nishu 12, Manikanta 5, fine. Now you are getting 2, 5, 6, 7, that is okay. But at least with your mistakes, are you learning or not? Have you learned what is your mistake? What is the wrong you have done? And I believe you remember, okay, that particular question we have to solve in this way. Like that, did you analyze? Did you gain the knowledge or not? That is important. Okay? Good guys, good work everybody. Next question. It's a break. So guys, BYJU'S Exam Prep. It is the single stop solution, a complete solution for all your gate needs and gate problems. So do recommend our BYJU'S Exam Prep for all your friends, whoever are preparing for the gate exam, and ask them to join our BYJU'S Exam Prep team. Okay. Chandan, that's okay. I appreciate you, Chandan, for your interest and for staying back all the time. Guys, claps for Chandan Kumar Jaiswal once. Saubhagya Nayak, Fibonacci series recurrence relation. T of n equals to T of n minus 1 plus T of n minus 2 plus some constant. Or you can even neglect that constant. You can at least remember n minus 1 plus n minus 2. Okay. Next. Let's proceed to next question. It's not going. Consider the following function from positive integers to real numbers. The correct arrangement of above functions in increasing order of asymptotic complexity. Thank you, Chandan. CSE fun. It means a lot. Thank you. Virender Singh, CS by Satya. You just type CS by Satya. You might get many, but with my image you can identify and join. Okay. (26) Bihar. Okay, Bihar means B. Okay. Yeah, definitely we can say a constant divided by some number would be less than a constant. So 100 by n would be less than 10. Then log n, probably square root of n. right? Option B. Next. The worst case running times of insertion sort, merge sort, heap sort respectively are. The worst case running times of these sorting techniques are. Yeah, it's a PYQ. CSC fun, I don't know your name. Please understand why this session we are doing. There are multiple benefits. One, every student know what are the total set of model questions, or what are the total set of popular, important, frequently asked questions from that particular subject. Second, you can checklist yourself, are you done with this PYQ, are you done with this model or not. Third, you can check your time management skill, so how fast you are able to give. And fourth, you can assess what is your performance in the competition. Alone you may be very great, but when you are competing with others, how well you are doing. Are you undergoing some pressure, some stress? So that you can know. And finally, you can know your mistakes and correct them. So there are many benefits of this. So we include PYQs to motivate you guys, because if I make all questions very hard, then do you attend? Would you get interested to go ahead with the questions? Generally no, right? So all kind of questions we mix. Okay? (27) all were giving C, but Muskan has given D. Insertion sort, worst case n square, merge sort, log n, heap sort, log n. Nothing more to explain. So n square log n, sorry, n log n, yeah, n log n. So it is option C. So guys, please do like the session. Make the number of likes 100 at least, as we are not getting the live count 100, which I have actually aspired for. That's okay. But guys, don't forget, or don't think like why I should share. Because if you share it, at least one is getting benefit out of these sessions. If at least one student learn one concept also from the entire session, that's it. The session is fruitful. So please try to share as much as possible, and please do publicity like it is a complete free session, right? So please give your feedback also. Are you enjoying, are you learning, are you gaining some confidence with these sessions or not? Please keep that. Okay, next question. It's again a PYQ. How many of you have solved it? How many of you have solved this? If so, what is your answer? Let f of n equals to n and g of n equals to n to the power 1 plus sin n, where n is a positive integer. Rohan Kulkarni, thank you. Manoj, same level means difficulty level could be definitely same, but the model could change this time. I predict this time they will work on preparing a different model questions instead of repeating the regular models. But it would be in the boundaries of the concept only. Okay. So D. I know. The answer is Don't you read the question properly? The answer is C, not D. I have changed it. Of course you can, and that is the simplest way to solve CSE fun. See, every time you need not to apply the standard procedures everywhere. Time saving. According to time, we have to go with that particular procedure. So you have to read the question properly, though it is looking like known question. Okay. Fine. Let's see. F of n is n, g of n is 1 plus n to the power 1 plus sin n. Now, for sin n, the possibilities are minus 1 to plus 1. This is the possibility. Sambhav Jain. Of course, it's a PSQ, PYQ. Just correct, I have modified to incorrect. So don't you read it? So g of n would be n to the power 1 plus minus 1. This would be n to the power 0, that is 1. If you take here 1 plus 1, n square. We know when you can write f of n equals to big O of g of n, when f of n is less than or equal to some constant c into g of n for n greater than or equal to n naught. So is n is less than 1? Here it fails. N less than 1 false. So when sin n is minus 1, this false. And f of n equals to omega of g of n, if you want to write, then f of n should be greater than or equal to some constant c into g of n for all n greater than or equal to n naught. Oh, you are going by heart. अच्छा, बहुत अच्छा कवर करते हैं आप लोग, हैं? By heart, by brain, by mind, by hand. The evaluating software don't know all this. Have you given the correct answer or not? That's all it knows, right? ये तो MSQ हो गया of course. So when sin value is 1, g of n becomes n square. Is n is greater than n square? No. So there it falls. So which is incorrect? Both are incorrect. Chalo. Next question. Consider the following functions. It is also P, S, P, Y, Q. Somehow, CSC fun. My dear students, it is also P, Y, Q. Now you don't trust me, right? That is required. You have to read the question. I want everybody to read every question completely and with care. Active reading is required. Yes. Life is full of surprises. पूरा ब्रेक लेंगे अभी और एक क्वेश्चन के बाद. ठीक है, व्हाट इज द आंसर? Again, let's say there is a function x, there is a function y. If x is less than c into y, then you can write x is equal to big O of y. If x is greater than c into y, then you can write x is omega of y. If x c1 into x is less than some c2 into x, if so, sorry, if so, x would be theta of y. Lot of static noise. Oh, it's clear here. Nobody? Anybody there? Nobody? Why you are getting lot of noise? Now it is okay. Is it fine now? Two to the power n factorial, n to the power log n. What would be the arrange? What would be the ascending sequence? Could you please tell me? Ascending sequence I want. Two to the power n. Okay, some noise. Even I have taken my mic also out. Yeah. which is bigger, 2 to the power n which is f of n, that is bigger than, yes, n factorial than n to the power log n. So I can say g of n is less than h of n is less than f of n. Is it so? Yeah, I am checking it. Wait. लाइट भी अभी निकाल दिया, बहुत सारे चेक कर लो।
Hello.
Please do refresh, guys. Now I think it should be fine. Please confirm. Is it clear now? Do refresh, guys.
Yeah.
Now I think it should be fine. Please confirm. Yeah, I think it's fine.
फोन हटा दीजिए, फोन चार्जिंग लेता है।
Oh, is it because of that?
Maybe difficulties.
Okay. Yeah. Could you please give me what is the correct sequence? H of n less than f of n less than g of n. Perfect. So I try to distract you. So this would be less than n factorial. Perfect, guys. So h of n is less than, f of n is less than g of n. As h of n is less than f of n, what you can write? H of n is equal to big O of f of n. Right? As f of n is less than g of n, you can write f of n is big O of g of n. In the other way, reverse, you can write f of n is greater than h of n. So f of n you can say omega of h of n. In the same way, g of n you can say omega of f of n. Not only this, h of n is less than f of n, which is less than g of n. So you can write h of n is less than g of n. Henceforth, you can also write h of n is big O of g of n. In the same way, g of n is greater than f of n, also greater than h of n. So g of n can be omega of h of n also. Right. Now f of n is big O of g of n. Right, correct. G of n is big O of h of n. Wrong. F of n is omega of g of n. F of n is omega of g of n. No. G of n is big O of f of n. G of n big O of f of n? No. H of n is big O of f of n, right? G of n is big omega of f of n, right? So option D. Perfect. An unordered list contains n distinct elements. The number of comparisons to find an element in this list that is neither max nor min. It's a very popular question, very easy question, and very good question also. An unordered list contains n distinct elements. Number of comparisons to find an element in this list that's neither max nor min. Yeah. You take any list 42, 15, 72, 60, 10, 30, 80, something like this. See, I want neither max nor min. So, if you take 42, if it is the biggest element, it should be biggest than all, right? So, 42 is greater than 15, 42 is greater than 72, no. So, definitely 42 is not biggest one. And if 42 is the smallest one, it should be smaller than all the other. 42 is smaller than 15, no. (42) is smaller than 72, yes. So, just by these comparisons, by comparing with the next two elements, we can say, yeah, 42 is neither max nor min. We don't know which is max, but we just want neither max nor min. So, just with two comparisons you can do that. So, two comparisons take constant time. That's why it is constant. If you want to find max element n, min element n, that again, if you go with linear search procedure, if you go with binary search, it is log n. Okay. All right. So, we will conclude the session with this. And I will share this PPT, I mean the PDF. I will share the PDF in my Telegram group. And for your sake, I know I would discuss only 30 questions today, but for your sake I have added 10 more questions. So those 10 questions are for your self practice. Okay. Virendra, come on. I take. Okay, Virendra, you tell me. 42, 25, 16. चलो मान लेते 42 I am comparing with 25. So 42 is greater than 25. 42 is greater than 16. From here what you can understand? 25 is less than 42. So definitely 25 is not the bigger one. And 25 you compare with 16 also. So 25 is not smaller one. Simple. So 25 is the neither max nor min element here. Right? Utsav study tips. Just open Telegram. Search for CS by Satya. Just search for this in the Telegram. You might get many, but identify this handsome boy and join. Okay? Yatin, that's why in the question it is clearly given distinct elements. Okay? So guys, I tried to cover all modal questions. If you identify, I have kept recurrence relation, forming recurrence relation for the given program, master theorem based questions, right? I have kept MCM, matrix chain multiplication question. I have kept arranging the given time complexities in the order, and I have kept asymptotic notations questions, and I have kept questions on greedy algorithms, that is job sequencing with deadlines, fractional knapsack problem, Distro algorithm, hashing based questions, sorting based questions, searching based questions, right? And I tried to cover all different models, or which are mostly occurring, most popular models, right? So I hope everyone have enjoyed this session while learning. So now I think Muskan Priyadarshini, that's really wonderful. Very happy to see that with this session you got confidence, means that's what we want. Great. So tomorrow subject is computer networks, my favorite subject, one of my favorite subjects. So let's meet tomorrow at same time 1:30 and let's practice CN questions. It's not simply coming, you do some preparation and come, guys. Okay? Great. Next marathon tomorrow itself. Right? Guys, give me some time. Maybe in couple of hours you will get the PDF. Okay? Chalo guys, see you tomorrow. Till then, have a great time. Take care. Bye-bye. Satya signing off.